Hey guys, before I start the new tutorial, I'd just like to say thanks very much for helping me get to 6,000 subscribers overall, and couldn't have got there without everybody, so thanks very much for the support, and I hope everybody continues to follow everything that I do. One thing that I'd like everybody to do is, if you'd be able to give my Facebook page a like, that would be really good, and help me, get the videos out to more and more people. So if you could, just like the page. I'll put the link in the description. Thanks very much. And this is one thing for anybody who's interested in art or hand art or digital art. I've got a very good friend whose YouTube channel is Learning As I Draw. If you search that, I'll put a link in the description. And he does a lot of digital art, can show you how to do digital painting, give you some tips. He's done a lot of good tutorials, and I think you'll really enjoy some stuff. So if you've got time, give him a subscribe. Thanks very much. So straight onto the tutorial today, and sorry about the delay, but we'll finally do what everybody's been nagging me about, is tree chopping. So I hope this helps people do what they want to do. So first of all, what I've got in my scene is I've made a series of prefabs that I'm going to use throughout my tutorials. So I've got one called a choppable tree, and obviously all you do to create a prefab is you can right click, create prefab, and it'll add a empty prefab. Then what you could do is, if you drag a tree mesh, any sort of mesh into your scene, you can just drag that onto the pre-made prefab slot, so you can drag that prefab in as many times as you want, and that's what we're going to be able to use to cut down our trees. So initially what I've done is I've brought in a tree mesh that I'm going to use to show the actual tree cutting. So first of all I've got on my tree mesh is that you want to make sure that it's got a rigid body on it. So you want to go component, physics, and then rigid body. And when it's got a rigid body, that'll mean it can fall over, and obviously because we want it to fall over when we cut it down. So you want to make sure that use gravity and is kinematic is ticked. We want to tick is kinematic, because if we apply this tree to a slope, if we don't, it'll just fall over straight away because it's got a box collider on. So that's my next step. Make sure that you add a box collider that sort of encapsulates the whole of the trunk, so it can stand up, and when it falls over, it'll land and won't fall through the terrain. And then monitor behavior is here, is just where we're going to add the script, because I've just deleted it so I can show it in this tutorial. You can keep everything the same, you don't really have to change the mass. I think I just changed it when I was testing, but that's all you need to make sure you've got the box collider and your rigid body. Now what I'm going to do is that I'll add this log sort of object that I made and make sure that that's in the pack when I upload it to the website. And also I've got a coconut. They're not really, they're only basic shapes with a quick texture on it. So all these two have is they both have box colliders on and rigid bodies, so they will, when we cut the tree, it'll spawn them and they'll fall down to the ground, so then we can pick them up. So all you need to do is obviously I've prefab these up, so you've got the rigid body, and just keep is gravity on these, and then make sure that the collider's all the way around the object, so when it hits the floor it can sit on the terrain. Okay, so that's pretty much it for the actual objects that we're going to use. So you need one tree, and then your logs and your coconut, whereas you can just use blank objects for this to test it out. Really, you don't have to have trees or logs or coconuts. So first of all, what we're going to do is we're going to create the tree controller, so the script that's going to control how much health the tree has and such, and instantiate in the objects when we need to. So what we're going to do is create a new JavaScript and call this tree controller. And then we're going to open up in MonoDevelop. And actually, as this happens in MonoDevelop now, what we can do in the script that we made last time, the player control script, you want to make sure that we change can swing to a variable rather than a private variable, so just delete the private. And that'll be all good to go, because we're going to reference it in another script that we're going to create. So now what we're going to do is, in the tree controller script, what we'll do is delete the two starting functions. And then we're going to have a variable called tree health as type integer equal to 5. And obviously this is how many times we're going to hit the tree to cause damage to it till it falls over. Obviously you could change this in the inspector when you want. We're going to have variable logs as type transform, variable coconut as also type transform, and then variable tree as type game object, and then variable speed as type integer equal to 8. And speed is going to be a thing that causes the actual force for the tree to fall over, so obviously you can change this depending on what you want it to do. Then we're going to write function start with 2 brackets, then 2 curly brackets below, and say that tree is equal to this dot game object. So that what this means is we're auto filling in, instead of having to drag each tree to the inspector, we're going to just make sure that whatever this script is on, it'll add itself to that slot, so we don't have to do anything. And then what we're going to do is make sure that rigid body dot is kinematic is equal to true. That's just in case you forgot to set it to true. Then what we're going to do is in the update function, I'm going to say function update 2 brackets, 2 curly brackets below, and we're going to say if tree health is less than or equal to 0, add the bracket, add 2 curly brackets below there, and we'll say rigid body dot is kinematic equals false, so we make sure that we'll be able to use gravity and fall over when the health is 0. Want to make sure that we say rigid body dot add force, so we're going to actually be able to push it over. Then we're going to say transform dot forward times by the speed that we initially set, and obviously make sure that this transform is a lowercase t, because we're referring to knocking it over rather than changing its actual coordinates. Then we're going to actually put a line break in, and then call another function called destroy tree, 2 brackets and a semicolon. Then what we'll do is we'll write another function here which we just created, and we'll call it destroy tree, and then we'll add 2 curly brackets below, and then we'll write yield wait for seconds, open brackets, maybe put in something like 7, and this is going to how long it takes for the tree before it falls over before we write our next line, which is destroy tree. So obviously you could change that 7 seconds to 10 seconds depending on how long it takes your tree to fall over, because I tried to think of a way that when it falls down, if it collides with the terrain, then destroy it, but it already touches the terrain to begin with. It's a bit buggy, and obviously destroy tree is just the tree that we set for this game object. Now we're going to actually instantiate the objects that we're going to create once it's destroyed. So we'll say variable position as type vector3 equals vector3 open brackets random dot range open brackets -1.0 comma 1.0, close that up, put a comma, put 0, add another comma, say random dot range again, open brackets -1.0 comma 1.0, 2 brackets and a semicolon. So what that's going to mean is we're going to spawn the objects in a random range between +1 and -1 in both instances, so it's going to just spread them out a little bit, like I did for the environmental item drop in my other tutorial. Then we're going to write instantiate open brackets, then we're going to write logs comma tree dot transform dot position plus vector3 open bracket 0, 0, 0, close that up, plus position comma quaternion dot identity, and then add a bracket and a semicolon. So what this means is we're going to instantiate logs at the tree's position, so where the tree was, and then we're going to add a vector3. So not for this one we're not going to change its position, but a vector3 means it'll change it in a particular x, y or z axis, and then we're going to say plus the position as itself, and quaternion.identity is just to translate the position for it when we instantiate objects. And then what we're going to actually do is I will copy this line, I'll paste it in again 2 times, and then what we're going to do is change this to 2 and to 2, and that to 5 and 5, and that just means that those are x, y and z, so we're going to move that 2 along the x, 2 along the y, and then that 5 across the x, 5 across the y, so they're all spawned slightly different to each other, and obviously you can change any of those. And then what we want to do is copy those 3, paste it in again, and we'll just change that object to coconut, because we're going to instantiate the coconut this time, and obviously paste that in. You can then change the positions if you want them to change, but for this I'm just going to keep it exactly the same just for the sake of this tutorial. Oh, one thing that I did is accidentally added an extra R to quaternion, so you need to make sure that it's just not got an R in after the A and before the T. So I'll quickly go through this script. So we're referencing the logs, the coconut and the tree. We're talking about the speed at which we're going to push it. We set the tree object to the game object that we set the script to. We'll make sure that isKinematic is true, so we don't happen to make the tree fall over. If the tree's health ever equals 0, so every time we're going to hit it in a minute, we'll make sure that the isKinematic is false, so we'll be able to knock it over. We'll add a force to that tree, and then once we've added the force, we'll call a function called destroyTree. We'll wait 7 seconds before we actually destroy the tree object itself, and then what we'll do is we'll spawn logs and coconuts at the tree's position at a random range between positive and -1, and in a random sort of variant. So we'll test that out once we've done the next script. So what you can do is, if on your prefab and on your choppable tree or whatever you've set it to, if you add tree controller there, you'll notice that when I've added it, it remembers my settings before. So we had the speed to 8. When you add your script for the first time, it'll have it in. It's kept the tree, it's added the tree name, and what you can do to the logs and the coconut is you can add your prefabs just in there to those 2 things, and obviously you can change your tree health when you want. So what we're going to do now is we're going to make the raycast so we can detect when the actual tree can be chopped. So what we can do is we're going to add another JavaScript and call this raycast chop. And then we'll open this up in MonDevelop, and what we'll do is we'll start by writing variable rayLength as type integer equal to 10. Then we'll say private variable tree script as type tree controller. Then we'll write a private variable player anim as type player control. Then we'll say function update, open brackets, and then add 2 curly brackets below. And then we'll say variable hit colon raycast hit. Obviously, before I start writing all this, if you know how to write a raycast or follow my other tutorials, you can sort of skip on this bit, because I'm just going to basically do a raycast, but then the main bit is when we actually hit the collider that we want. Then we want variable forward is equal to transform direction, open brackets, vector3 dot forward, close that up, add a semicolon. Then under there we'll say if physics dot raycast, open brackets, transform dot position, obviously make sure that that transform is lowercase, comma forward, comma hit, comma ray length, close 2 brackets, add 2 curly brackets below that. Then we'll say if hit dot collider dot game object dot tag is equal to tree. Then we'll add 2 curly brackets below there, and then we'll say tree script is equal to game object dot find open brackets hit dot collider dot game object dot name, close that up, dot get component open brackets tree controller. So I'll explain what I'm doing so far. So obviously we're just doing a simple forward raycast, and then if we've hit the collider, which is going to be our tree, so in Unity make sure that your tree has a tag of tree, so your prefab can have that tag, doesn't matter how many trees you have. And then what we're going to do is we're referencing the tree script, so it's the tree controller that we just created to add to all our trees. We're saying that we're finding the game object that is the one that we're looking at any one time. So if we've got multiple trees, we obviously don't want to be hitting one and then it knocks them all down. We want to be only looking at the one, so it's looking at the collider that we're hitting and the game object name of that. So, and then we're going to find the component of tree controller. So obviously I'll show you how to do multiple trees. Then we're going to say player anim is equal to game object dot find open brackets, and then my name of the game object which the player control script is on is fps arms underscore axe at idle. Obviously you can change that to something more simple, and then you say dot get component open brackets player control, close that up, add a semicolon. Then under there what we can do is we can say if input dot get button down open brackets in quotes fire 1, which is left click, close that up. Then we'll say and player anim dot can swing is equal to true. Remember when I said earlier in the tutorial that we wanted to set can swing to a public variable so we could see it in this script. And then what we're going to do is add 2 curly brackets below there and say that tree script dot tree health minus equals 1. So this means that we can't take the damage away from the tree unless we can swing from the other script, so we can't just, even though we're not playing the animation, hit it a million times. We're setting it so we can only do it as the animation cools down. So we'll go back into Unity. So now my prefab has my tree controller and everything on, and then my tree in the scene has it on as well, because if you change the prefab and the prefab object will change in your scene as well. So what we could do, add to the main camera, raycast chop, and then you can see that the ray length is set to 10. Now if we go up to this tree, what we can do is, if you watch on this side, you'll see the health. You'll notice that I'll play my game, I'll walk up to my tree, you'll notice that I hit it once, hit it twice, 3 times, 4 times. My last time, you'll notice that the tree will fall, and obviously we wait an amount of time, 7 seconds, and it'll spawn the items that we're actually looking for. So obviously you want to be able to make sure that you can make as many trees as you want. So obviously maybe people can find a better way of spawning your trees, but I can't really make it to work where you paint trees on the terrain, so you can make it quicker. The only way I can think of doing it is if you have this tree and you take this tree and you duplicate it, so you can duplicate it and put it back here, and I'll make sure it's a bit close to the ground, and then I change its name to tree choppable 1. So obviously you could hide this all in an empty game object to stop the cluttering of your scene, but as long as you name it to 1, 2, 3, 4, 5, 6, 7, 8, 9, however many trees you want to be able to be choppable, the script will always work. So if I show you now, this tree, even though it's all floating a little bit, if we hit it once, twice, 3 times, 4 times, 5 times, I may have just missed it that time, but that one falls over and our other one doesn't, so we'll obviously spawn our objects. Obviously we can move over to this tree and do exactly the same thing. But it does different things every time you add force, so it doesn't always fall over 100% now, seeing as they've got rigid bodies in, they're all away. So you obviously need to just change them and mix it up. But obviously you can make it work with however many trees that you actually want to have in your scene. So you can have 100, but as long as they're named with slightly different names, it'll always find them really easy. And as I always say, it's not 100% bug free. It's something to, get everybody with a basic idea, and you can expand on it and change it and sort all these issues out that there might be with it. So, as ever, thanks very much for watching, and I hope this really helped everybody out make the scripts that they always wanted to make, and hopefully this helps you make one step towards your survival game. So thanks very much for watching, and don't forget to like, comment and subscribe, and if you've got that extra bit of time, don't forget to like my Facebook page. Thanks very much.